Hi everybody, today we are continuing our work with the standard form of a quadratic relation and now discussing how we are going to graph from that form. So we have learned in previous chapters how to graph from factored form and vertex form. So let's just recall. From factored form, we find the zeros, use the zeros to find the axis of symmetry and the vertex, and then we can also find the y-intercept and its symmetrical partner. So for example, if we had y equals x minus 1, x plus 3, we could find that the zeros are 1 and negative 3, average those two to find the x value of the vertex, put that back in to find the y value of the vertex. Those are 3 points we can plot. We can put in 0 to find the y-intercept, its symmetrical partner, etc. Okay? Now, if we were given vertex form, so something like y equals negative 2 x plus 3 all squared plus 5. In this case, we can use transformations. So we start with x squared and our 5 key points. Then we would reflect and stretch by 2. And then we would move everything left 3 and up 5 to get our parabola. So because we started with 5 key points on x squared, we would transform all 5 to have 5 points on our new parabola. Today we're going to learn how to graph if we are given an equation in standard form. So one way is to basically put it into factored form and find all the information. Okay, so this is method number 1, which is essentially just put it into factored form and do all the stuff we did before. And this is method number 2. So rewrite the equation in vertex form and use transformations. So let's see how to actually do this. So in this one, in these 2 examples, the first 2 examples, we're going to use factoring to graph it. So this is a factorable relation because we have 2 numbers that multiply to 7 and add to 8. So x plus 7 and x plus 1. So that means my zeros are x equals negative 7 and x equals negative 1. Okay, it's actually even better to write them as coordinates so that you don't end up just writing it as 1 point. Okay, notice that I labeled zeros there. I didn't just write it in the middle of nowhere. I'm keeping my work neat and organized. Also notice that I didn't have to show solving these equal to 0 because we're just using it to graph. Okay, otherwise if it said find the zeros, you should set the equation equal to 0 and show your solving. So now I'm going to be organized again and just tell my reader here that I'm finding the vertex. So I'm giving a little subtitle. So the x value of the vertex is I average my 2 x intercepts to get negative 4. And then I find the y value by putting negative 4 back into the equation. So in this case, I get this is 16 minus 32 is negative 16 plus 7 is negative 9. So my vertex is negative 4, negative 9. Okay, and then lastly, I can find the y-intercept. Now this is actually more useful to look up here because if you put in x as 0, you can easily see that y would be 7. Okay, and then another point or its partner. Okay, the axis of symmetry is at negative 4, so it would be over at negative 8 would be another coordinate with a height of 7. Okay, so notice I didn't just draw my axis right down the middle of here because let's think about this. All my x-intercepts are both negative. My vertex is negative, so really I don't need anything. So I'm going to put my y-axis way over here because all the x values I'm using basically are negative. I need to get down to negative 9 and up to 7. So I'm going to put my axis here, but then I'm going to do my scale is going to be by 2 so I can fit everything. So 2, 4, 6, 8, negative 2, -4, -6, -8. So this is my x-axis and my y-axis, but this is just going to go by ones. Okay, so I'll use a different color to graph. Okay, so -7 is here, -1, 0 is here. My vertex is at -4, -9, which is here. And my y-intercept is at 7. And then I have a symmetrical point here. So again, on this trackpad, guys, honestly, I'm so bad, but hopefully you can draw a better parabola. I often find it simpler going from the vertex and up in either direction rather than trying to go from left to right. If you try to go from left to right, it can get a little bit tricky. Okay, and then I would want you to label your 5 points here that you filled in. Okay, so I won't do the other 2, but that's what I would want you to do with your equation as well, and arrows. And notice I didn't just stop at those last points, I continued the parabola on and upward. Okay, let's do another one. So this one isn't quite as clean. We're gonna do it anyway. So again, I don't put my axes until I know where everything is. So this is a complex trinomial. So in terms of factoring, I find it simpler to actually, if it's a negative a value, I like just common factoring that out. I find it simpler to that, but that has to stay out there. Okay, I find it simpler to do it this way. So then I need 2 numbers that multiply to -12 and add to -1. So that's -4 and +3. So I keep the negative out here, and I would have 2x squared minus 4x plus 3x minus 6. And I would take that. So I would have 2x, x minus 2, plus 3, x minus 2. So I'd end up with negative 2x plus 3 and x minus 2. So from this, I can see that my zeros are 2, 0, and then -3/2, 0. Okay, I'm just taking this and setting it to 0 and isolating x, and I'm taking this factor, setting it to 0 and isolating x. So 2 and -1.5. Okay, now I'll find my vertex. Okay, so the x value of the vertex is 2 minus 1.5 divided by 2. So that is 1/4. And the y value of the vertex, if you put it in, you will get 6.125. So I can actually keep this as 0.25. Okay, so at this point, you kind of have to make a decision about if you want all of your labels, I'm just checking this, if you want all of your labels to be fractions or decimals, because notice right now, this is a fraction and this is a decimal. So when I actually draw it, I need to choose. I can't have some as fractions and some as decimals. All right, and then I want to find the y-intercept, which I can see is 0, 6. And then I'll have another point at 0.56 because the axis of symmetry is just at 1/4. So I have one 1/4 on the other side. So this is a bit of a squished up situation. It's not overly clear how to do this. So notice that the zeros are from 2 to -1.5. So, and all my y values are above 0 that I'm graphing. So I'm going to do a graph with my y-axis here and my x-axis here. But my x-axis is going to go up by 1/2 Or you know what, I'm deciding actually I'm going to even do it up by a quarter because I only need to get as far as 2 and negative 1.5. So if I go, here's a half, here's 1. So here's a half, here's 2, and there's 2.5. So in the other direction, there's negative a half, there's negative 1, and there's negative 1.5, which is where my zeros are. So that is a way to keep these small numbers showing up nicely to make the scale larger. And then on the way up, my vertex is 6.125. So let me see, 1, 2, 3, 4, 5, 6. I don't have enough room on this, so I'm going to just go up by ones here. So, but if you had more space, I would suggest maybe going up by 0.5s. Okay, so let's actually label this. So negative 3.2 is negative 1.5 and 2, 0. Okay, my vertex is at a quarter and 6.125, so just above 6. And then here's my y-intercept and my axis with symmetrical partner. And I'm going to connect those. And remember, this would continue. I don't just stop at the x-axis. Doesn't look the greatest, but that's the idea. Okay, so now you would label all your points. All 5 of your points you would label, even if you kind of need to do something like that. And you label with the equation. Okay, so that is this first method, which involves factoring and then finding all that information. The other way is to convert the equation into vertex form and then use transformations. So this might actually be preferable because then you don't have to factor. Also, not all parabolas are factorable and they don't all have x-intercepts. So vertex form is a way of ensuring that it will always work even when your quadratic is not factorable. So to do this, the first step is to find the vertex using our method of x equals negative b, so negative 6 divided by 2a, so 2 times negative 1. So this is negative 6 divided by negative 2, so the x value of the vertex is 3. Now the y value I find by putting 3 back in, so that would be negative 9 plus 18 minus 9, which is actually 0. So in this case, my vertex is 3, 0. And now I'm going to use the same a value, which is negative 1. So my equation in vertex form is y equals negative bracket x minus 3 bracket all squared. And then I could put plus 0 if I wanted, but I don't need it. Okay, so let's recall how to graph using transformations. So notice that this will be reflected down and then going to the right 3. So there is a reflection on x-axis, and we're going to translate right 3. So let's picture what that looks like. So we're going to be going down and to the right. So I need to put my x-axis in the middle so that I can draw my original parabola and the reflected one. So let's start with just our 5 key points of a quadratic. 1, 2, 3, 4. So if this is like really, foreign to you, and you really do not remember this, you should go back to the video on graphing using transformations, which was in Unit 4, where we go into this in detail. Not pretty, but you know, sometimes we do what we do. Okay, so those are the 5 key points of my quadratic. 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. So first step is to do the a value and reflect. So I have my 0, 0 still, but both of these y values go down to negative. So now I have 1, -1, -1, -1, 2, -4, and -2, -4. So I have stretched my y values. Sorry, I have reflected my y values. Okay, and now to get my final parabola, switch to pink here, I'm going to translate right 3. So I just take each of these points and go 3 to the right. To the right, to the right, to the right. And there you go. So there is your parabola. Gorgeous. Okay, let's do that again. Graphing, as much as you want to get away from it, is really important. All right, so our vertex is, our x value is -b, so that would be +4 divided by 2 times 2. So that's just 1. And so my y value of the vertex would be 2 times 1 squared, so 2 minus 4 minus 1, which is -3. So my vertex is 1, -3, and my a value is 2. So hopefully I didn't go through that too quickly, just finding the vertex, just like we did in our maxima and minima note. So now this equation in vertex form is y equals, okay, same a value, 2 bracket x minus 1, because our x value of the vertex is 1, and then subtract 3, and don't forget the squared. Okay, so let's think about the transformations. So this is a vertical stretch by a factor of 2, and then we're going to translate right 1 down 3. Okay, so it's going to be stretched up and then go down 3. So I'm going to put the y-axis right in the middle. I know I'm going to need to go down 3, so I'm going to put my x-axis here. Wait, oops. Go away. Why is it doing that? I don't know why it does that sometimes. Okay, I apologize for that, guys. So I'm going to put my x-axis right here, because that will allow me to still go down 3, but then I can stretch up nicely. So I'm going to start with my original parabola. Okay, it doesn't have to be super pretty because it's just the one we're using to transform. Okay, so step 1 is to do the stretch by 2. So all of my y values are twice as high. So 0, 0 stays the same, but instead of being 1 high, this is 2 high, both of these. And these, instead of being 4 high, have to be 8 high. So all the way up to there. So all the way up to 8. Okay, so I have stretched vertically by a factor of 2. Okay, and now I can do both of my translations in one step. So I go right 1, down 3. So I just like starting with the vertex, going right 1 and down 3. Taking this, going right 1 and down 3. Right 1, down 3. Also check it, my y-intercept is -1, which matches standard form. Right 1 and down 3. Right 1 and down 3. So there you go. The pink one is my final parabola. Okay, so that's the one that I would label with the equation, and those are the points that I would label as well. All right, so those are the 2 different methods, 2 examples of each. This word problem, so this is helpful. I like this in 2 ways. One, because it shows us a different format, because you might not know how to factor this right away, and also because it's within a context. So it's saying that they are using this equation to model the arch. So h is how high it is in meters, and d is how far it is from the center. So part A is asking us how wide and how tall is the arch. So it is helpful for us to graph this arch to fully see this. So our equation is h equals negative d squared plus 16. Now you might look at this and say, Mrs. Weens, this is not factorable. What is going on? But let's check this out. What happens when we factor out a negative 1? What happens is that we have a difference of squares inside the bracket. You should have thought about that. 16 is a perfect square. So this actually factors to negative d plus 4, d minus 4. So our zeros are negative 4, 0, and 4, 0. So let's put our center right down. Oh my goodness, I was really thinking this would be straight and it's not. Let's put our x-axis. So this is our d-axis and our h-axis. So we know that our zeros are 4 and negative 4. Okay, so let's find our vertex. So the x value of the vertex is, well, we can average these two. Minus 4 plus 4 divided by 2 is 0. Or, I mean, you could have used common sense. It has to be a 0 distance away from the center of the arch. So actually, instead of x there, my bad, I should have put d. And so the h, I put in 0, is 16. Okay? So my vertex is at 0, 16. So I'm going to go up by 2s. 2, 4, 6, 8, 10, 12, 14, 16. So I do need to show somehow that I went up by 2s. All right, so my parabola basically looks like this. Okay. So how wide is the arch? Well, we can visually see here that the width is 8 meters because this is 4 meters and this is 4 meters to get a width of 8. And the height is 16 meters since that is the h value of the vertex. For what value of d is the relation valid? Explain. So for this, we would say all real numbers between negative 4 and 4, since height has to be greater than or equal to 0. Okay, the height of the arch has to be above the ground, and those are the values for which h is above 0. So again, seeing the graph visually helps us understand that. A banner will be hung 8 meters up the arch. How wide must this banner be? So at 8 meters, there's going to be a banner. So 8 meters, it says, yeah, 8 meters up the arch. So we need to figure out this width. And in order to do that, that means we need to figure out these x values or the d values where it's hitting at 8. It looks like it's at 3 meters, but we actually are going to solve the equation to find out for sure. So our equation would be, where is this minus d squared plus 16 equal to 8? So for what d values is this equation true? So because we don't actually have a d value, we only have a d squared value, we actually can isolate d in this case. So we can actually move the 16 to the other side to get negative d squared equals negative 8. Okay, and again, we can do this because we don't have a d squared and a d, just a d squared. So now you divide both sides by negative 1 to get d squared equals 8. Now here's the key. Remember, when you undo a square root, you have to do positive or negative the square root of 8. Okay, you have to do both the positive and the negative square root. So let me just check my answer here. So that is 2.8. So that means the total width would be 5.6 meters since it's 2.8 in either direction. Final question here. So in this case, we're given a parabola, and notice that they want us to write the equation in standard form. Okay, so what we have to do first is to find the equation in factored or vertex form, and then we convert to standard. All right, so I'm going to do this one in vertex form and convert to standard. And then next class, when we're talking about this, I'll do the other method as well to show that you get the same thing. So I do challenge you to try that on your own to see if you can do that. So I'm going to do vertex form. So the vertex is 3, -2. So I set up my equation, y equals a x minus 3 all squared minus 2. So I'm going to sub in another point, 1, 0, to solve for a. Okay, so I get 0 equals a bracket 1 minus 3 all squared minus 2. So 0 equals a -2 squared minus 2. So 0 equals 4a minus 2. So 4a equals 2, and a is 2/4 or a half. So my equation in vertex form is y equals a half x minus 3 all squared minus 2. So now I just need to use FOIL or my special product to get this to standard form. So you have two options. Either you can rewrite this as x minus 3, or you can use your special products to and your rule for perfect squares to get right to this expansion. Okay, so again, whatever you do, just don't assume that this is x squared plus 9. That's not true. Remember that this is the same as x minus 3, x minus 3. So again, either you can FOIL that and collect like terms to get to this, or you can use your pattern for perfect squares to get right to this. Okay, so now this half is distributed to this bracket, but not to the -2, since that's not part of the bracket. So I get a half x squared minus 3x plus 9/2 minus 2. So now I just need to collect these like terms. So I get a half x squared minus 3x, and then that is 5/2. Okay, alternatively, you could write it as 0.5x squared minus 3x plus 2.5. But what you can't do is have one fraction and one decimal. You need to have either one or the other. So that was a long note about a lot of stuff that we learned, but you will be using these skills a lot when we get to problem solving coming up. So take a look at the success criteria and please write down any questions you have. So thanks for watching. Hope you learned lots.